I want to just have a quick footnote to what we're doing and briefly sideways step what we're coding and thinking about by telling you about a concept which, if you like, is fundamental in the way that object-oriented code and programming built itself. And if you're clear about this, so many of the problems and issues in your coding will make a lot of sense. In the language of C, there was something called a pointer. Think of it like this, right? A pointer was a little piece of data. So if this is a pointer data, the only thing it did was it pointed to an address location in which some data or object sat. Now I'm kind of mixing up my concepts a little bit, but that's the ampersand is often used as an address, a way of indicating an address in code. So the idea was that you had a type of data which was a pointer, and its only job was to point to address locations, and in those address locations you would have bits of data, objects, etc. sitting. Okay, it did not point to a piece of data, it pointed to the address of that data. To specify a pointer, you had to also specify the type of object you were holding there. You couldn't just point it randomly to anything. You had to make it aware of what type of data. So C was before object-oriented programming came about. And the reason that it existed is that if your code constantly needs to move bits of data around memory, it has a huge overhead. Okay. So the logic of these pointers, and this is the concept behind how the linked node works, because the linked list comes directly, if you like, out of this concept. And it goes right down to C. Because there was an overhead for moving data and moving objects. So if I had a method and I had to copy that object to the new method, then I'm using a lot more memory than I need, and secondly, there's an overhead. It takes the system a bunch of processes to make a copy, to push it to another place, and for you to manipulate it. The pointer came about because all your data sits in your RAM in address locations. Right, so these are all address locations. And what C programming development showed was that you can actually allow the data to stay in that location as long as you know what the location is. Then if you pass that address, the location of that data, around using these pointers, the pointers also have a process called dereferencing. And this process was really a mechanism to get to the data from the address location. So in the early history of programming, this notion of a pointer appeared quite early as a powerful mechanism to stop you from moving data around your memory. Remember, this is hard, this is your RAM, okay? And these ampersands represent different addresses, simplified obviously. C is very close to the hardware layer, and this is still why it's a very, very important language. The pointer was invented to stop you moving data around, but actually sharing the address of that data. Anyone who had access to that address could manipulate the data by dereferencing the pointer, which would then give me back the actual data inside there. Now, fast forward to languages like Java, C++, including Visual Basic, actually .NET. That's object-oriented. You've also got C#. You've got a whole range of different languages. And what they do is that they effectively use the concept of a pointer, but they no longer use pointers. So what they do is, when I create an object, so if I say I've got a class called n class, and I create a little object from it, and I use the new keyword, and there's my constructor, and I do that line. That line there, right, and that object, this new keyword means that I'm going to occupy a location in memory. So obj will sit in there. Okay, when you create an object from a class, you need to load it up to a particular location. Now, if I have a second object, and that's my Nadim class, and I create a second object, say I just call it that, I don't create an object from it, and I do this line. If I say object2 equals object, superficially that just simply looks like I've taken object, and wherever object2 is sitting, somewhere else, right, I've made a copy and I've copied it over. That's what it kind of looks like. I've taken object and I've put it into object2 when you look at that code. Now, this may seem to you very, very trivial and obvious, but it isn't obvious and it isn't trivial, and it's very important you understand what I'm about to say. When you assign one object to another in this way here, right, you've created the object, the second one is just a reference to that object, and then you assign that. What it actually does is it takes the address of the original object and makes that the same address as for object 2. So object 2 and object both have the same address. That's what the assignment operator does. So under the covers, it's like a pointer. It's basically sharing the address. You're passing the address over, and object 2 takes on, I use the ampersand, the address of object 1. And that's absolutely critical to what we are going to be doing when we're looking at exceptions and issues and so on and so forth.